So in our second module, we will begin with a brief discussion on this whole concept of systems because it might seem somewhat repetitive. I hope it's not too repetitive, but the idea is that we really do not fully understand and appreciate systems, and when we don't understand and or appreciate systems, we end up making all the wrong decisions, taking all the wrong actions, which actually cause us half of the problems or perhaps all of the problems that plague us in our place of work. And so we'll talk about systems, understanding what systems involve, and how to really work with a systems perspective. So what is a system? A system basically consists of a number of interacting subsystems or components which work together in order to achieve a common purpose, which is the purpose of the system as a whole. Okay, and note that when we talk about a system and we talk about the components of the system, the components in and of themselves do not have an identity of their own. Okay, so when we talk in terms of, for example, our human body, the human body is a fantastic system, and you have various parts of the human body which interact with each other, and they provide your total output, which is the health and the energy for us as individuals to work and enjoy and operate on a day-to-day basis. However, if you were just to take the stomach or the heart or any other part of the arm, that in and of itself does not have a individual or an independent objective. Okay, it is something which has to be seen in the context of how it interacts with something else. Okay, and so you have to look, when you think in terms of a system, when you think in terms of a car is a system. Our society is a system. The world is a system. Okay, towns are systems, and each one of these have subsystems and components. Of course, if you take a particular set of components which may then themselves be part of a larger system, you have to understand that when we are talking about a particular system at one level, we have to talk in terms of the components of that particular system and not that system as a part of a larger system. Okay, generally when we talk about a system, there are several processes, there are several methods and steps that are required or which are undertaken in order to help achieve the overall system objective. And let's say we talk about a pizza parlor as a system. Okay, a pizza parlor or a place or a restaurant that sells pizza. Now, in order to make pizza, there are a number of different processes. One of the processes that exists in a pizza restaurant or a pizza parlor is making pizza dough. Okay, that's what goes into the base of the pizza. So the process here could be the making of pizza dough, and the method by which we can achieve this particular process is we can either roll out the pizza dough by hand, or we can feed it through a machine that would flatten out the dough which would be required for making the pizza base, or in some cases people hand toss the dough in order to make it round and flat. So there could be a number of different methods which can be used for the purposes of making the pizza dough. A step in this method, if we talk about rolling the pizza dough by hand, could be to dust the work surface with some cornmeal, okay, which is like basically corn flour, before rolling out the dough, so that the dough does not stick to the surface. So each one of these things has a certain hierarchy, and ultimately the process ensures that we are able to achieve the end of the system, which is to have the pizza made, which is the objective of the system, which is the pizza parlor. We have seen the Deming flow diagram a couple of times, and the reason I am sharing this again with you over here is because we need to understand this in the context of today's lecture, because we are going to be talking about the customers. Okay, and we will be having a slightly simplified version of the Deming flow diagram, which I'll share with you in just a minute. But remember that in the Deming flow diagram, we had a system which had a certain objective, which was to satisfy the customers. The customers are not part of the system. The customers are outside the system, and they provide inputs into the system. The rest of the elements that you see over here, from the production system to the suppliers, okay, and the distribution as well, all of this can be considered as part of the system, with the customers or the consumers being outside of it. And the system consists of all of these individual components or subsystems, and each one of these needs to work in alignment with the others. So the suppliers need to understand what are the design requirements based on feedback from the customers. They need to supply the materials as required by the production or assembly departments or the assembly areas in manufacturing. Within the production system itself, each production process needs to understand what their individual requirement is in order to be able to achieve the end result, which is to have a complete product ready for the customer, and so on and so forth. Okay. A slightly simpler version of this is shown here, and this is called a CPOC or an SIPOC model, and it really takes the Deming flow diagram and just expresses it in a slightly simpler fashion, where we have a supplier, and the supplier provides some input, and the input then is input into the process, which is the way or the place where we make our product, and the output from this is the product or the service that we are in the business of providing, and this is then sent to the customer. So CPOC or SIPOC comes from the first letters of the supplier, input, process, output, and customer. And the thing that one has to bear in mind when we talk about the CPOC model is there is the idea of a purpose, and the purpose is the one that actually drives the entire system, starting with the supplier, the input, the process, the output, etc. Because if there is no purpose, the system has no direction, and the system really would be chaotic and be doing things that is not in any unified manner or direction. So when you talk about purpose, we say that a system has to have a purpose. A system without a purpose is not really a system. It is just a collection of objects or components or subsystems. So in order for us to really be talking about a system, we need to consider an objective or a purpose. The purpose of this system actually defines the relationships among the system components, because how else would the system components interact with each other? Okay, the interaction has to lead to the achievement of this purpose or objective, and therefore the system purpose is essential for the sake of defining the system or the component relationships or the component interactions. The purpose not only defines what it is that the system should accomplish, but also what it should not do. Okay, meaning that let's say that if we have a system that produces cars, so one of the things that would be the purpose of this particular system would be to provide means for vehicular transportation of people. But at the same time, what is a requirement or a part of the purpose of the system is that it should not pollute the environment, okay, that it should not be consuming too much of the resources, natural resources in terms of water or other resources such as electricity, which is not a natural resource obviously, but these are again part of the purpose or a sub-purpose, so that the system design can take into account the fact that or take into account the needs which are broader than just a single statement of purpose of that particular system. Also, as we've been mentioning, any individual component of a system cannot have a purpose of its own, and it cannot be independent of the system that it is a part of. So again, if we, as I mentioned to you, if you take a look at a car, for example, what is the purpose of the engine of the car? Okay. Now you cannot define a purpose for or a brake. What is the purpose of the brake without looking at it in the context of the interrelationships with other components and looking at it in the context of the overall system purpose or the system objective, because the brake is supposed to stop or slow down the vehicle as a whole, but by itself, what is it that the brake is supposed to do? There's no real purpose that you can assign to it. Similarly, the transmission, or if you take a look at the fuel injection system, or if you take a look at the any of the other subsystems in a car, where you have to align the purpose of the components or the subsystems to the overall system itself. When you talk about the purpose ideally should be in most business types of systems to meet and hopefully exceed the needs of the customer. Okay, you need to understand and satisfy what the customer requires, because without that you will not exist as a business. The purpose would be to provide whatever features and quality characteristics we are required to provide, and part of the purpose would be also to achieve whatever capabilities we need in order to provide the above two purposes. So broadly we can think in terms of the purpose being to meet and meet the needs of the customer, providing all the quality characteristics, and developing and acquiring the capabilities to provide these above. Now the problem that we tend to have in a number of industrial or business organizations is that although we talk in terms of a system consisting of components that are required to work together in concert to achieve a common objective, the unfortunate part is that we have come to accept in our current understanding an organizational structure which is functionally organized, meaning that we have departments which are based on individual functions such as finance, such as engineering, such as manufacturing, such as marketing, such as purchasing, such as logistics, etc., etc. Okay, and each one of these functional units, functional departments, which are really individual components, is given a certain objective. And the unfortunate part is that if you're not very careful, and I've seen more cases of this, as I'm sure a number of you have seen as well, is that the objectives of these individual functional units in an organization tend to be at cross purposes, which is what we tend to see over here. Okay, one department wants to move in one direction, For another one, it is better to move in this direction. For somebody else, it is best to move in the opposite direction, and so on. Okay. As an example, what we can say is that if marketing perhaps would like to see more variety so that they can sell more products to the customer, but from the standpoint of manufacturing, it is more difficult to provide a larger variety. Okay, so for manufacturing, they would ideally prefer to produce one single product, okay, in very large quantities, because they would need to set up the equipment very few times. Of course, if you're talking about lean, there are other ways around that, but this is just an example of how or why the functional objectives are not necessarily in alignment. Ideally, what you would like is you would like for all of the components and the subsystems to be aligned in a way that they all basically work together in sync with each other and provide the achievement of a common system purpose, as we see over here. And for this, you need to ensure that the objectives of these individual organizations or individual subsystems is all aligned, that you are not trying to do sub-optimization by trying to optimize the individual components, but you try to look at the overall system behavior. Some examples where you will see non-alignment and alignment is if you take a look at a company that perhaps wishes to reduce cost, and most companies do wish to reduce cost. And one of the things that we will end up doing is we will look at direct materials, because in a lot of cases direct material cost tends to account for more than 60-70% of the total cost of production of a particular part. Okay, and so if more than 60 or 70% of the total cost of production is in direct materials, then quite obviously a reduction in the direct material cost should end up giving us a good reduction in the total production cost. But the problem is that when we ask purchasing to find cheaper materials, now that is not the same thing as reducing cost. There's a difference between a purchase price and the total cost of ownership of a certain part or a product. Because when we try to look for cheaper materials, purely going by the unit price, the cheaper material could possibly be of inferior quality, especially if the purchasing person is really not well versed in the quality aspect of the particular material or the product, and this possibly could cause more rejects and more scrap in manufacturing. So in this case, what you may find is that one subsystem or one component of the overall system, which is purchasing, is meeting its goal, where its goal was to bring about a reduction in the cost of purchased parts. But on the other hand, another part of the same system, which is manufacturing, ends up getting beaten down because its performance actually suffers. And when the performance of manufacturing suffers, most likely your customer satisfaction level suffers, because manufacturing is what ends up putting out the product for the customer. And if the number of rejects goes up, the time that it would take to complete a customer order, as well as the cost at which that customer order would be achieved, will tend to go up, and therefore the customer may have to end up paying more, paying a higher price. And so the question is, who wins in this case? Is it the company, is it purchasing, or is it manufacturing? And if purchasing wins but the company goes down, who wins in that case? Okay, so it's sort of a no-win situation unless we understand that we are dealing with systems and we are not dealing with individual entities such as purchasing and manufacturing who have their own existence. In the US, it's a well-known fact that grocery stores, large grocery stores where you can walk in and buy what you need, things like eggs and milk, which are considered to be consumer staples, things which people need every week, every few days, and these have not really gone up very significantly in price, at least over the last 30-35 years that I am aware of, which means that these are typically sold either at a loss or at minimal profit. But the reason why these are typically sold at a very low cost is because people look to find deals for milk and for eggs, because these are things that they need on a daily basis, and so when there is a good price on milk and eggs, they will go to that particular store, and the store hopes that when you come in to purchase the milk and eggs, and they will typically position the milk and eggs so that it's right at the back of the store, and you have to pass the entire store before you can get to the dairy and the eggs department, and so hopefully you will purchase some of the other items which are priced obviously higher, and that is where the store makes its profit. Okay, but if you were to think in terms of the dairy department as a separate entity, its performance would be very poor, because they are not making any money on the milk and eggs, which are a significant part of, even butter for that matter, is not sold at a significant profit. It's a very low price item. But the fact is that the store as a whole obviously benefits, because the person coming into the store will also buy this, and will buy something else, and will buy some cookies, and will buy some cereal, and will buy some meat or some other vegetables and so on, and that is where the store ends up making its money.